here we go. All right, so here's the first one that we have. And so what this person did is they broke down the prime factorization of 72. So if I wanted to break that down as well, I'm going to do 6 and 12.
Yeah.
Are we okay with that? And then as I broke down 6 and 12, I got 2, 3, 6, 6, 2, 3, 2, 3. Now, this one's a little bit more unique because 36 is a perfect square. What I mean by it is if you take 6 and you multiply 6 by 6, that's where they're getting that from. Yes, Carter?
I think it's supposed to be 6 times 2.
Yeah.
6 times 2. Thank you, thank you. Good catch, good catch. Thank you, Brian. I know you saw that as well. Okay? The reason they didn't break it all the way down is because they just knew the perfect square. So if you just want to understand what those are, well, the perfect square of 2 is 2. Perfect square of 3 is 9. 4 is 16. 5 is 25. You follow what I'm going with those? It's that number times itself. We talked about it last year in one of our earlier units, but that's where we're at. So if we're to list out the prime factorization of this, it's going to look like this. 2 times 2 times 2 times 3 times 3. Or we could write it in a more simplified version, 2 to the third times 3 squared. You okay with that so far? Now, how many did I say you have to pull out? 2. Well, how many 2's do I have? 3. So I'm going to pull out A2. How many 3's do I have?
2.
I'm going to pull out A3. And what's left in my house? Just 1, 2. Okay? And then the last thing I got to do is multiply the 2 times the 3, which gives me 6 radical 2. Yes, Addison?
So is the extra 2 like the third 2? Like
The third 2? Uh-huh.
Yeah, because it's 2 to the third, so you're bringing out 2 and then leaving the extra.
Correct. Correct. Now if I add 2 to the fourth, how many 2's could I have pulled out?
2 and then
2, and then there'd been nothing left over, right? Okay. Yes, Andy?
I don't get how you went from 3 squared to 2 times 3 and then 2. Like, what happened to that other 3?
So there's like a magic invisible 2 here. It's called the index. And what that means is in order to pull a number out, you have to have 2 of that same number to pull out. So by having 2 3's, I could pull both of them out, which just becomes 1 3 on the outside. Same thing with my 2's. I had 3 2's. I had to use 2 of them to get it to the outside, which left my 1 lone 2 on the inside.
So you put them together, but they're still the same number?
Yeah.
Okay.
Yes, Colin?
So if it has a 2 or greater than exponent, then you pull out 2, put it into, well, pull out 2 from, I
You're
don't
good.
know how to word it.
You're good. Just try. You got nothing to lose here. You want to think on it and come back to it?
Yeah.
Okay. All right, over here, we're going to take 48. We're going to break it down again. I'm going to do 4 and 12, is that right?
Yeah.
2 and 2, 2 and 6, 2 and 3. So if I rewrite this, I now have 2 times 2 times 2 times 2 times 3, or 2 to the fourth times 3. Are we okay with that? All right. If I have 4 2's, how many 2's can I technically pull out? 2 of them, right? So I'm going to have 2 times 2 radical 3. Can somebody tell me why that 3 is staying inside the radical sign, Charger? There's only one of them, right? So I can't do anything with it. Do we agree that 2 times 2 is 4?
Yes.
Radical 3. Yes, Steven.
Are we gonna have an exponent on the outside? Like, on the outside of the radical?
Like to the right or to the,
To the left.
like here on the index? You can. We will not in this class.
Okay.
So when I say I've overtaught this for the last couple of years, that's what I've done. I've tried to include the different variables or different exponents. I mean, sometimes you'd have 3, sometimes you would have 4. But after I've read over the TEAC and talked to some other teachers, I don't think that that's necessary for what we're trying to accomplish. I'm under the impression that the only number you'll ever see on the index is the 2. Okay? Yeah, Ian.
So I know you need at least 2
So like right here, I had 4. And that's why I pulled out 2 2s. So if there had been 5, I would have pulled out 2 2s and left 1 2. Okay? Now, let's look at some more. Yeah, what's up, Georgia?
Well, what? See, if you only pulled out 2 of the 2s from 2 to the 4th, why is there none left? What'd there be like?
Because when you pull out the 2, you have to have 2. 2 on the inside equals 1 on the outside. This is a great example. How many guys have been to an arcade? Okay, you go to the arcade. You have to put in 2 coins to get 1 credit, right? So you put in 25 cents, nothing happens. You put in 50 cents, and it says 1 credit on the screen, like it's flashing on the bottom. That's what this is. You have to put in 2 of these from the inside to get 1 on the outside. Does that make sense?
Yeah.
You're buying your credit, and this is basically the money slot. And to put it out, you have to put out 2 coins to get 1 credit on the outside. That's all it is. Does that help give you a better visualization? Okay. Okay, so here's a couple more. Let's look at these. These ones, again, are using some perfect squares. I'm just using them for examples. I know that they're not breaking them all down perfectly because, once again, they have the perfect squares. Not every question is going to be a perfect square. I mean, you saw the example from the warm-up, so I'm just using these to kind of give you a baseline, and then we'll do a couple of examples and move past it. All right, so Addison, pick one of these 4. I don't care which one.
Example 5.
Okay, Addison chose example 5, so we're going to look at that one real quick. So we're going to break down 125. Is everybody okay with that? And what I'm going to do is I'm going to write it over here. Somebody tell me, what do I have to multiply together to get 125? Daniel?
25 and 5.
5 and 25, do we agree?
Yes.
And what is 25 broken down? So what I have is 5 times 5 times 5, or 5 to the 3rd. Okay, how many 5s do I have to remove from the inside to the outside? Stone?
2.
2. And so if I take 2 of these 5s, put them on the outside, that only becomes 1 5. 2 from the inside become 1 on the outside. 2 on the inside become 1 on the outside. How many 5s are left?
1.
That's your answer. Yeah, Zane.
Can you have a decimal whenever you break it down?
No, we're not having decimals because we're breaking down with only prime numbers, and so that's why that's why you have to break them down first to avoid any decimals. Other questions? Okay, yeah, Connor, what's up?
So how come? Wait. So if those weren't all 5s, if you had 2 of 2 numbers, like 4, 4, and 3, 3, what would you do then?
4, 4, and 3, 3. So you pull the 4 out, you pull the 3 out. There'd be nothing left under the radical. So I'm gonna write this out. This is just the scenario Connor just made up, okay? So let's say that I have this 4, 4, 3, 3, 4 squared, 3 squared. Well, first of all, I just want you to realize we would never have 4 squared because that's not a prime number, agreed? I just want you to see that. I'm just doing this for Connor's sake, though. Can I pull out the 2 4s? Can I pull out the 2 3s? Do I have anything left?
No.
So your answer would just be 12 after you multiplied the 4 and the 3. Brian,
Do one where it's like not a perfect square.
do one where it's not a perfect square? Yeah, I'm working towards after this. Yeah, Steven.
So on the outside, like on the other problem, you had 2 times 2 on the outside of it.
Uh-huh.
So would you make that 2 squared or just leave it 2?
Nope, it would be 2 times 2, which would become 4. 2 times 2, which would become 4. Which I guess is the same thing as 2 squared. So yeah, that would work, but I would want you to multiply it out. So give me the actual number, though. All right, cool. I think there's some after this that do not have the perfect squares, so I'd like to look at those. There we go. Let's look at number 4. This is example number 4 here. And again, I know it's already worked it out, but I want to just work it out with you so you see the pieces. We're going to break down 75. Okay. I think we can agree it's 3 and 25. Yes, no? Break down 25, so this one does have a perfect square, so which is 5 and 5. But now we have the radical 3 times 5 times 5, or 3 times 5 squared. What can I pull out?
The 5.
The 5. So then I end up with 5 radical 3. Easy enough?
Why did they have 35?
Why do they have 35?
Yeah.
Oh, because they had the 7 in front of it.
Okay.
Okay, are we all okay with it? Alright, let me show you. That's a great question. We're all okay with me breaking down the 75 that way?
Yes.
Alright, now, when I rewrite this, notice that it has a 7 in front of that radical sign. So when I rewrite the problem, it's going to look like this. Or, okay, is everybody still okay with that? I'll tell you about the 7, but do you understand how I wrote everything? Nothing changed except for there's a 7 in front of the radical sign. What am I pulling out from inside the radical? Charger? The 5. So now I've got 5 times 7 radical 3. So that 7 was just already a part of the problem. And so now once you pull out your numbers from the radical symbol, you're just going to multiply whatever you pull out by that 7. What is 7 times 5? 35 radical 3. Does that make sense? Okay. Let's see if I can find a couple more. No, we don't need those. Okay, here's what we're gonna do. We're down to 12 minutes left in class. I'm gonna go ahead and end this, and I want you to go ahead and pull your homework out. I'm gonna let you start working on that, and then I'll answer questions based off of those as we come across